Hey everyone, and welcome. I am absolutely thrilled you're joining us today. We've got a brand new explainer for you, and we are focusing on one of the most foundational, genuinely powerful tools in the entire modern computing landscape, Amazon EC2. We're going to look at exactly how this service takes rigid physical servers and transforms them into a flexible, fully programmable cloud blueprint. It's a real game changer.
So, I want you to imagine a scenario. You launch a brand new web app, and boom, it goes viral overnight. Your traffic just spikes right off the charts. Now, in the traditional IT world, you'd be forced to guess your peak traffic way in advance. You'd have to buy ridiculously expensive physical servers, wait weeks for them to ship, physically rack them in a data center, set up the networking, and then, on top of all that, pay for the electricity to run them 24/7. And if that traffic spike is higher than you guessed, well, your servers crash from the overload, and there's just no way you can buy and install new ones fast enough to save your app.
Okay, let's dive into this and really contrast that painful reality of being chained to physical hardware against the completely friction-free environment of AWS EC2. Instead of buying physical metal, you're essentially renting virtual computers up in the cloud. You can boot a server up in under a minute, scale it out to literally hundreds of instances when that viral traffic hits, and then, and this is absolutely key, you can shut them down instantly when the traffic drops, so you stop paying for them. It's instant, pay-per-second cloud computing.
Now, to navigate this entire ecosystem safely, we're going to follow our blueprint to building framework. First, we'll cover core concepts, then architecture flow, move on to implementation, tackle cost optimization and security, and finally, we'll wrap up with troubleshooting and cleanup.
All right, Section 1, Core Concepts. When to choose EC2 versus the alternatives.
So the ultimate elevator pitch for Amazon Elastic Compute Cloud, or EC2 as we usually call it, is that it provides secure, resizable compute capacity in the cloud. Honestly, just think of it like renting a highly customizable virtual machine that's running in one of Amazon's massive data centers. And the key phrase to remember here is full control. You get total control over the operating system, the memory, the CPU, the storage, the whole shebang. You can run almost any application or legacy software you want on it.
Now, EC2 is incredibly powerful, but it isn't the only tool out there. As you can see in this decision matrix, we can map out exactly what you should use. For short, event-driven serverless code, you want AWS Lambda. If you're deploying containerized microservices, look at ECS or EKS. Standard web apps where you don't want to mess with server config, Elastic Beanstalk is your friend. But when you need full OS control for custom software or to port legacy apps, EC2 is your undisputed champion. Really, it's only the wrong choice if your workload runs for unpredictable, short bursts of seconds, or if you just don't have the bandwidth to handle regular OS maintenance.
Let's move to Section 2, Architecture Flow, and see how this builds. We'll be looking at the basic building blocks of a request.
To build confidently, you really need to understand your hardware options, which AWS neatly categorizes into what they call instance families. Think of this as choosing the actual muscle of your virtual machine. As this chart lays out, you've got three main options. First up, general-purpose instances, like the T3 or M5 families. These give you a great balance of CPU, memory, and networking for standard web apps. Got some heavy batch processing or media encoding? You'll want to scale up to the compute-optimized C5 family. And for blazing fast, in-memory databases, you'll want the massive RAM that comes with the memory-optimized R5 family.
Okay, let's look at this diagram and trace how a web request actually routes through this architecture. Traffic from an end user enters your isolated cloud network right through the internet gateway. From there, the route table directs that traffic to the specific subnet where your server lives. But right before it touches your server, it hits the security group, which acts as this strict instance-level firewall. If the security group gives it the green light, it finally reaches your EC2 instance. The instance acts as the brain, processing the request and reading or writing persistent data straight down to its attached virtual hard drive, which is called an EBS volume.
Section 3, Implementation. Building a production-ready server. When you're launching in the AWS console, please do not just blindly click Next on the default settings. You want to build a tailored setup. First, select a stable, long-term support OS like Ubuntu or Amazon Linux. Number 2, pick a fixed performance instance like an M5.large so you don't get hit with unexpected CPU throttling. Third, download and secure your RSA key pair locally. Seriously, if you lose this file, you lose access to your server. Fourth, lock down your network security group strictly to your own IP address. And finally, upgrade to the newer, cheaper, and faster GP3 storage. And always, always check that delete on termination box so you don't leave orphaned hard drives lying around costing you money.
And here's a really cool pro tip. You can actually completely automate your configuration. By pasting a simple user data bootstrap bash script into the console right during launch, the server will automatically update the OS, install your web server, and start running the app on its very first boot. You literally never even need to manually SSH into it. It's awesome.
Moving into Section 4, Cost Optimization and Security, protecting your data and, of course, your wallet.
Now, security in the cloud operates strictly on the principle of least privilege. This is absolutely crucial. First, at the network level, you must never, ever expose your structural layers, like your databases or back-end code, to the public internet. Hide them away in private subnets and just use an application load balancer to route the traffic. Second, at the access level, let's say your EC2 instance needs to read from an S3 bucket or a DynamoDB database. Do not hard-code your AWS access keys into your application code. Instead, create an IAM role with the absolute bare minimum permissions needed and attach that directly to your instance. AWS will handle the credential rotation securely and automatically for you.
1 minute. That is the absolute minimum billing cycle for an EC2 instance. The very second you pass that 60-second mark, you are billed strictly on a per-second basis depending on your instance type and OS.
And this brilliantly illustrates what actually drives your bill at the end of the month. As you can see in this donut chart, your costs are split into 3 main buckets: the actual per-second instance runtime we just talked about, your attached EBS storage space, which is billed per gigabyte, and data egress, which is the cost of sending any data out of AWS and over the open internet.
Now, to optimize those runtime costs, take a look at this bar chart comparing the 3 pricing models. On-demand is your fixed, 100% baseline cost. But if you commit to a 1 to 3 year savings plan, you can slash that bill by up to 72%. And if your workload is highly flexible, you can actually bid on Amazon's unused capacity using spot instances for a staggering 90% discount. But wait, there is a massive catch with spot instances. 2 minutes. That is the incredibly short warning time AWS gives you before they instantly reclaim your heavily discounted server. And that is exactly why you only use spot instances for fault-tolerant, flexible workloads.
Finally, Section 5, Troubleshooting and Cleanup. What to do when things inevitably go wrong.
Okay, here's your rapid-fire troubleshooting guide. If your instance won't connect and you just can't SSH in, immediately verify your security group rules and double-check that your local public IP hasn't dynamically changed on you. If you see that only 1 out of 2 status checks passed, well, the underlying OS likely crashed on boot. Go straight to the instance actions and check the system log. And if your service performance suddenly craters on a burstable instance, head over and check the CPU credit balance metric in CloudWatch. Chances are you've exhausted your burst credits and you are being heavily throttled.
So the crucial point is this: AWS EC2 shifts your infrastructure from a rigid, expensive physical liability into flexible, highly programmable software. It hands you complete administrative control to deploy applications globally in seconds, just as long as you embrace the responsibility of maintaining and securing that environment.
And honestly, a huge part of that responsibility is cleaning up after yourself. To avoid those nasty, unexpected bills, simply navigate to your dashboard, select your instance, click Terminate, and confirm. The virtual machine and its attached storage are permanently wiped out, which leaves us with this final, provocative thought. If you now hold the power to spin up and tear down a secure, global infrastructure in mere seconds, what's stopping you from building your next big idea today? Thanks so much for joining me on this explainer, and keep building.